Hello viewers, in this video we will see the solution to week 5 assignment 5 for the course analog communication. The solutions are our suggestions. Question 1, which of the following is the characteristic benefit of using analog envelope detection for demodulating AM signal? We'll see the solution. So option C, demodulation process is simple. Demodulation process is simple. So option C is it simplifies the demodulation process by avoiding the need for carrier recovery Option C. Second question is why is coherent demodulation necessary for SSB-SC signals? So the answer for this is filter out noise. Option A. Filter out noise. Third question, we'll see. Third question, 1 second please. Which modulation technique provides the best performance in terms of bandwidth efficiency? The answer is option D. Single sideband suppressed carrier. Option D, single sideband suppressed carrier. So option D, single sideband suppressed carrier. Next we'll move on to the fourth question. So fourth question is, in the context of vestigial sideband suppressed carrier modulation, what does the vestigial part of the signal refer to? So it is the portion of the other sideband. Option B, it is the portion of the other sideband. Next question, fifth one is consider a periodic signal x of t of time period t, and this signal is passed through a filter which is having so infinite filters with following cutoff frequencies and following delays. So the answer for this question is none. Option D. Sixth one, find the Hilbert transform of the following signal, and omega 1 is greater than omega 2. Okay, so here the answer for this question is sixth one. So sixth one you can see the so this is m of t is the given cos omega 1t cos omega 2t. So this can be expanded applying cos A cos B formula, omega 1 plus omega 2, and this becomes omega 1 minus omega 2, and for this each term you apply a Hilbert transform. So cos becomes now sin omega 1 omega 2, and this becomes sin omega 1 minus omega 2, and again we will apply sin of A plus B formula, and this is sin of A minus B formula. So what we get here is, after applying the sin of A plus B and sin of A minus B formula, we will get sin omega 1 t cos omega 2 t. So answer is option C. Seventh question, this is a single sideband signal is generated by modulating signal of 900 kilohertz is the carrier, and this is m of t is the modulating signal, and we have to see what is the answer for this question. We will see here. We will see now. 1 second. Seventh one. So seventh one and the LSB terms for the given message signal and the carrier signal is you will have two LSB term. 50 cos 2 pi fc minus 1000 t and minus 100 sin 2 pi fc minus 100 t, and this expression is not there, is not given as an option, is not given as an option. Therefore answer is, therefore the option is D. Option is D. Option is D. None of this. None of this. None of this. So next, eighth question. Eighth question. So this is the given spectrum of the message signal. We need to find what is the minimum and maximum bandwidth of the filter. So that is, we'll see here. That we'll see here the minimum and the maximum bandwidth of the filter. I have shown here the one side of the spectrum. Okay, so this is the, this part is USB and this part is LSB. We want only LSB part. You can see here the bandwidth. The bandwidth of the LSB is 0.1, and I have also shown the characteristics of the bandpass filter. So minimum bandwidth is 0.1, and the bandwidth, another one is maximum bandwidth, bandpass filter characteristics. This rectangle shows the another characteristics of bandpass filter, which is the having a maximum bandwidth. So the maximum bandwidth is 2.6, 0 to 2.6. So therefore the answer is option A, 0.1 and 2.6. 0.1 and 2.6. Option A, 0.1 and 2.6. 0.1 and 2.6. Option A. Next question, ninth question, 10 signals each band limited. So this is 10 signals they have given for multiplexing, each having a guard band of 2 kilohertz. We'll see this one. This question is multiplexing. So 10 signal has to be multiplexed, each having a bandwidth of 6 kilohertz, and the guard band is 2 kilohertz. We will see the solution. The solution for this is very simple. You can see 10 signals they are given, each having bandwidth 6 kilohertz, and the guard band is 2 kilohertz. So total bandwidth is equal to total number of signals. The number of signals multiplied by bandwidth is 10 into 6, plus we have only 9 guard bands. So each guard band is having 2 kilohertz. Therefore 78 kilohertz. 78 kilohertz is the answer. Option A. Answer is option A. Option A. Option A, 78. Last question, 10th question. So 10th question, QAM signal M1T cos omega t, M2 cos sin omega t. So we'll see the solution for last question for QAM demodulation. So the QAM demodulation. So m of t equal to m1 cos omega t plus m2 cos omega t. I will consider the first term. You can see here the given carrier is omega. Plus delta omega. So we will consider the first term here, m1 cos omega t. It is multiplied with the carrier. This is the carrier signal, and by applying the trigonometry identities, what we get here is this part, 1 by 2 m1 cos delta omega t. Other are sideband terms which are filtered by the low pass filter. This is for the first term. Similarly, for the second term, what we get is it is m2 sin omega t, and this is the carrier which is having a frequency drift of delta omega. We will get a low pass signal as minus 1 by 2 m2 sin delta omega t. This is the low pass signal. So these two are the outputs. So this is the output. This is the actual output, 1 by 2 m1 t cos delta omega t minus 1 by 2 m2 sin delta omega t. But in the options, plus is missing, plus sign is missing. Therefore I consider this as null. So option is D. Option is so D. Thank you.